guys, welcome back to another Dynamics, Physics in the Flesh problem. 2 blocks with pulley on an incline. A. Suppose the coefficient of kinetic friction between M1 and the plane below is mu k equals 0.14 and that M1 equals M2 equals 2.6 kilograms. As M2 moves down, determine the magnitude of the acceleration of M1 and M2 given theta equals 25 degrees. And B. What smallest value of mu k will keep this system from accelerating? So, one thing at a time. We are already given this diagram here, so we know it's an incline problem, angled at theta equals 25 degrees, so that's there. Now, if you saw the previous videos, just the previous few videos where we're dealing with an incline and an object on an incline, usually the object is sliding down. Okay? And in that sense, we always let positive be down parallel to the incline. However, in this question, it tells us that M2 is moving down. If M2 goes down and M1 and M2 are connected with the same string, M1 is going up the ramp, in which case I want to actually define positive to be up the ramp. And another thing to remember is that because we're dealing with these new types of problems where we're on an incline, we want to define a new coordinate system. Okay, so for example, y is going to be perpendicular to the ramp, and instead of x being down in parallel, x is going to be up in parallel. And this, mind you, is just going to be for M1. M2 is going to have the same coordinate system up and down. Okay, so these are our positive x and y directions. Okay, so although I have this great diagram here, I'm going to go ahead and draw my own free body diagrams. I'm going to start with mass 1 here. Okay, so I'm going to do that first. So here's my incline. Here's my mass 1. And I'm going to start drawing the forces acting on mass 1. Of course, there's a force of gravity because M1 has a mass. So that goes straight down, Fg, right? Because gravity always goes towards the center of the Earth. M1's on a surface, so there's going to be a normal force perpendicular to that surface. So there's my Fn. Right? M1 is being pulled up the incline by a string, so there's going to be a tension force going upwards, Ft. And lastly, the question tells us that there's a bit of resistance between the block and the ramp. That's called kinetic friction. Okay, so that's going to be down and parallel to the ramp. And I'll call that FFK. So we've got 4 forces in total. Now, because Fg is not in line with these 3 that are all perpendicular to each other, I'm going to break up Fg into x and y components as per my definition here. So I'm going to put the y component of Fg like that, and here's the x component. Those two meet at a right angle. So I've got my Fgx here, Fgy up there. And you see that angle there, theta? This angle here, which is 25 degrees, is the same as this angle here. And as I've stated in previous videos, it's a simple trigonometric calculation to show that these are in fact the same angle. Okay. So there is the free body diagram for M1. Now I'm going to do the same thing for M2. So I'm going to do that free body diagram over here. M2 is very easy. There's only 2 forces acting on it, and that's tension going up because the string is going up, and we've got force of gravity going down. Okay, so this will have its own coordinate system. So for this, we'll just have up be positive. Or rather, you know what, let's let down be positive for this because M2 is moving down. Okay, so let's let positive be down. So we've got our F tension, we've got our F gravity, free body diagrams for 1 and 2. And here's the thing, I don't need subscripts for my Ft or my Fgs. Otherwise I normally would because I have 2 different blocks, but I don't, because both masses are the same and they're connected with the same string. Therefore, tensions are the same and weights are the same as well. Okay, so that's what I wanted to explain to you first. Now, given the free body diagram, we can now go under Newton's second law for this block, and we'll do the same thing for that one. Okay, so these problems all follow a very similar scheme. You've got 2 objects. They're connected with a string. There's tension. So you end up creating 2 equations, one from each free body diagram, and you end up with 2 unknowns, tension and acceleration. 2 equations, 2 unknowns. Mathematics tells us that now we can solve for one of them. And that's pretty much the gist of these problems. Okay, so starting off, Newton's second law, I'm going to say F net x 1 equals ma. Okay, and this acceleration is going to be in the x direction, but we can just call that a. Okay, so the net force for this and the x. Now, you see here how I broke up FGY and FGX from FG. Make sure you understand what direction those forces are going in. Okay, FGY, from the middle of the box, FGY is going down. So this vector is going down. But based on the center of this object, FGX is going to the right. Okay, so just make sure you remember that it's not going to the left. Based on the middle, if you cut this in half, this vector is more on the right side. Not to mention, if you did vector addition, these two have to add up to the hypotenuse. But anyways, okay, let's keep going. So f net x1 equals ma. Okay, now in the x direction, in the positive x, I've got ft, and in the negative x, I have ffk and fgx. Okay, so I'm going to replace f net equals ma, well, the f net part, with ft minus fgx minus ffk equals ma. And that's what we're looking for here. We're looking for that acceleration there. Okay, so now fgx, notice that you've got a right angle triangle here. First thing you should think of when you see a right angle triangle is SOHCAHTOA. Okay, and SOHCAHTOA requires the hypotenuse here, right? Sine, cosine, tangent. So for fgx, what we can say is that fgx is equal to the hypotenuse, which is fg, also known as mg, times the sine of the angle, because it's opposite theta. So fgx is mg sine theta. Likewise, fgy is going to be mg cosine theta. So just have that there so you can always reference it. I'm going to need this one right here to sub it in. Okay, so ft minus mg sine theta. Now for ffk, force of friction is always given by the following relationship. Force of friction is equal to the coefficient of friction times the normal force. Now, if it's static friction, you put the coefficient of static. Kinetic friction, coefficient of kinetic. Here we're dealing with kinetic friction. What you have to figure out is the normal force. And we're going to do that by looking at the net force in the y direction for this first block. F net y1 equals 0. Okay? For this block, we know that it's simply sliding up the ramp. It has no motion in the y direction. It's not accelerating. Therefore, the net force in the y direction is 0, meaning the two forces in the y direction, which are Fn and Fgy, they must balance each other out, because then you get Fn minus Fgy equals 0. Again, the only two vertical forces. Fn equals Fgy. And I just stated Fgy is mg cos theta. So we can actually write Fn as mg cos theta. All right. So that is going to get plugged in over here for FFK. I'm going to use that. So FFK minus mu k Fn equals ma. There's my Fn. Then we're going to plug it in there. So Ft minus mg sine theta minus mu k mg cos theta equals ma. Okay, lots of masses there, but I don't have a mass there for this term, so I can't just cancel it out. Okay, I can't simplify this too much more without making it look more complicated, so I'm going to leave it as is for now. I'm going to start working on my second equation there, okay, my second object. Okay, so this object only is dealing with net forces in the y direction, so here we go. F net y2 equals ma. Okay, so there we go. In the y direction, we let down be positive, so Fg minus Ft equals ma. Fg is simply mg. Ft is Ft equals ma. Okay, now, hopefully you recognize something interesting here. Notice that I've said ma is equal to this expression, but ma is also equal to this expression. Okay, and because they're both ma, the masses are the same, the accelerations are the same, the products must also be the same. So what I can actually do is set these two equations equal to each other. Okay, so that's what I'm going to do next. So here we go. ft minus mg sine theta minus mu k mg cos theta is equal to mg minus ft. Because this is ma, this is also ma. So I can set the two equal to each other. Okay, so at this point now it's simply simplifying it at this. Okay, now I've got ft here, I've got a minus ft on the right side of the equal sign. I'm going to bring that minus ft to the left, okay, and at the same time I'm going to bring this minus expression and this minus expression to the right. So everything comes out positive. That's what you want. Okay, so if I bring the minus ft over, I'm going to get 2ft. Okay, and then bringing the other objects to the other side, you still have that mg there. And then we do plus mg sine theta plus mu k mg cos theta. So hopefully that's so far so good. Now, part A is asking us to determine the acceleration. So once we figure out the tension, we'll just figure out the acceleration. We'll plug it in to one of our equations. So I need to get force of tension by itself. Right now it's being multiplied by 2, so divide both sides of this expression by 2, and you get Ft equals, you know what, why don't I do one more step here? I'm going to also factor out mg. I think this will make it a little bit cleaner. Okay, so hold on, let's do the factoring out mg first. If you take out mg, we're going to get 1 from the first term, we're going to get sine theta from the second term, and we're going to get mu k cos theta from the third term. Okay, so that's okay. We factored out mg. Now imagine dividing both sides by 2. Because this is a product, I don't need to necessarily write it in the entire thing over 2. I can just write the over 2 right there. It means the same thing. Okay, now at this point, I believe I can just plug in my numbers and solve for what I need to solve for. So Ft equals m, masses are all the same. It's 2.6 kilograms. G is 9.8 newtons per kilogram. Divided by 2, bracket, 1 plus sine 25 degrees plus 0.14 cosine 25 degrees. Okay. So, simplifying this expression, this initial part here is going to give us 12.74 newtons. And this second part right here, this is just a number. You're going to get 1.5495 unitless. Okay, multiplying the two of those together, you're going to get 19.74 newtons. So there's our force of tension. Now, how did that get us closer to finding acceleration? Well, remember these equations here? This entire expression is equal to the product of mass and acceleration. This expression is equal to mass times acceleration. Now, we want to use the easier one, unless you want to do more work, which I don't. Okay, so I'm going to plug it into here. I've got my Ft, mass I know, G is known, mass is known, find acceleration. So I'm going to use that equation down here. So let's do that here. Our equation was mg minus Ft equals ma. So if you want to, let's bring the ma to the left, the mg minus Ft to the right, and divide both sides by m. So you're going to get mg minus Ft over m. So plugging in your values, your mass is 2.6 kilograms, G 9.8 newtons per kilogram. Subtract Ft, we just found that, 19.74 newtons. Divide it all by 2.6 kilograms. And when you do that, you are going to find that acceleration equals 2.2 meters per second squared. Okay, that was a very long part A. Okay, but there's your acceleration, 2.2 meters per second. That's for both blocks, the one up the ramp and the one going down on the side. Okay, so that's done. Now let's take a quick peek again at part B. What smallest value of mu k will keep the system from accelerating? Okay. So, to keep the system from accelerating, that implies something very straightforward. Acceleration is equal to 0. Okay, so for part B, we know that A is going to be 0, but we're going to go ahead and use this equation we had before because the free body diagrams still hold true. Therefore, this expression also still holds true, except in this case, we're going to set the A equal to 0. Okay, so mg minus ft equals ma. And of course, I just said because that's 0, 0 times anything is 0. So the entire expression disappears. So therefore, we can say that mg is equal to ft. Ft is equal to 2.6 kilograms times 9.8 newtons per kilogram. So force of tension is 25.48 newtons. Okay, so there's that. The next thing we want to do, we're looking for the coefficient of kinetic friction. Now, between the two equations, the only one that actually displayed us the coefficient of kinetic friction was this one right here. Okay, the ft minus mg sine theta minus mu k mg cos theta equals ma. We're going to use this. Okay, so let's just go ahead and copy that down here. Okay, so ft minus mg sine theta minus mu k mg cos theta equals, now check it out, it equals ma. Again, a is 0 here, so I'm just going to go ahead and set the right side equal to 0. Okay, so we got that going. And remember, the ft is the new ft, the one we just calculated, 25.48. That's what you're going to plug in here, not the old one. Now, I'm trying to get mu k by itself. So what I'm going to do is take the expression that it's part of and move it to the right side of the equal sign to make it positive. Okay, meaning I'm going to be left with ft minus mg sine theta equals mu k mg cos theta. So ft, 25.48 newtons, minus 2.6 kilograms, 9.8 newtons per kilogram, sine 25 degrees, equals, again, 2.6 kilograms, 9.8 newtons per kilogram, cosine 25 degrees, mu k. And that is what we're looking for. Okay, everything else is just a number. It's simply a matter of plugging it into your calculator. Okay, so this entire expression on the left, when you enter it in your calculator, you're going to get 14.712. Okay, on the right, this first part right here before the mu k equals 23.093, and your mu k drags along. Okay, to get mu k by itself, divide both sides by the 23.093, and you will get mu k equals 0.637. So that was long, but one more step. We have to make sure we round this to the correct number of sig figs. Okay, the least accurate value in our problem, in fact, in this case, it was all the values. They only had 2 sig figs. So we round this to 0.64. And as always, the coefficients for friction are unitless. Okay, so you don't put a unit, it's simply a ratio. Okay, so there is your answer for part B. In order not to accelerate, to keep the system from accelerating, that is your coefficient of kinetic friction. Wow, that was pretty long, but that's it, guys, for this video. I will see you in the next one where we will be starting circular motion and gravitation problems.